Hello and welcome to this Cubit tutorial for openCFS. This is an introductory video, so if you want more information on special things like mesh algorithms and so on, please have a look at the openCFS YouTube channel or the Coreform Cubit tutorials. In this video, I want to construct the following model with two domains and two different mesh sizes. But before I get to that, I want to give a short overview over Cubit itself. In the task bar, we have all the usual stuff, creating new documents, saving them, importing and exporting things, and also something called a journal editor, which I will get to later. Then you can enable and disable the undo functionality. I would always keep that enabled. And you can also change how your model is displayed. To the left, you have your model tree. Here, all the things that you created are displayed. Currently, that is empty as I have just deleted my model. Down at the bottom, there are 4 tabs: Python, Command, Error, and History, of which the Command and History tab are the most useful, and of course, Error is never to be underestimated. In the command line tab, for example, you can type in commands directly if you want to. If you don't know the commands by heart or don't want to type them in, you can also use the command panel to create all sorts of things. And we are going to use the first 3 modes today. And usually one starts with creating the geometry, which is also what I'm going to do now. So I'll create the operation create geometry, and I'm going to start by creating some vertices. These can be created by different methods. I'm simply going to create them by typing in the location. So I want my first vertex to be at 0, 0, 0. The second one at 1, 0, 0. And the last one at 0.5 and 0.5. Next, I want to create a line between the lower 2 and an arc between the upper 3. So I'm going to create the line first. And I'm going to create the line with the vertices I've just created. I can just click on them, and then the vertex ID is going to show up here. I could also just type in the vertex ID, and if I don't know my which vertex has which ID, you can find them in your model tree here. So I'm going to create my line and my arc, and I'm going to use the 3 vertices method. So this time I'm going to type in the indices, and as I want the arc to go from here to there to there, the correct order is 1, 3, 2. So that is going to create my arc. And last, I want to create a surface. I do this by defining the bounding curves. And again, I can just click on them. If you want to click on more entities, keep your control key pressed. Okay, so now if I have a look at the history file, I can see all the commands I've used so far. So we created the vertices, the curves, and the surfaces. And this is very useful because if I now click on the journal editor, one can see that I've already created, I've already copied those commands, and I've also changed the coordinates slightly. So I can now run this journal file, and it will automatically execute all those steps. And one can see that I have now a second semicircle within my original bigger semicircle. So this is it. So a journal file is especially useful if you want to create some models quickly, and if you want to create models that are similar. So then you can create one journal file and you can only change 1 or 2 lines according to the changes you want. So now that our geometry is finished, I want to go to meshing. There are different kinds. You can mesh with different algorithms. You find them here. So there you can just simply choose out of this map these options. I have had good results with the PAVE algorithm. But as this is a comparatively easy model, I will simply use automatic sizing. And as I want my whole model to be meshed, I simply select the bigger one and apply the meshing. And then I can see that I have a problem because it totally ignored the smaller semicircle and only gave me a more or less consistent mesh over the whole bigger semicircle. So this is not what I want, so I undo this. And now I'm going to look for a way to tell Cubit that that it should include this semicircle and that is in fact a different region. So how can I do that? I can do that by using the merge and imprint function. Note that this usually works better with volumes. So I'm gonna so I have 2 volumes here. I have the first and the second. So I'm gonna type those in and click apply. And at first it seems like nothing happened, but if I turn the visibility of this one off, I can see a faint line where the semicircle used to be. And if I click on the volume 1, we can see now that it consists of 2 different surfaces, which is exactly what I wanted. So now I can go back to meshing. Again, I'm going to use automatic sizing. I'm going to start with this smaller one and mesh it. And now I can see that I have a much finer grid here. Then I'm going to mesh the second one. And we can see that we have a conforming grid at the interface and that the grid gets much coarser, which is what we wanted. So in the end, I also want to define some nodesets. Nodesets are used to later in openCFS define boundary conditions and so on. So if you want to define a nodeset, you should keep the nodeset ID empty because Cubit is automatically gonna assign a nodeset ID. But you should definitely include a name as this is then later needed in openCFS. So I'm gonna call this lower boundary. And it should be a curve. And I'm gonna simply select the lower curve here and hit apply. So again, it looks like nothing happens, but if we go to the model tree, we can now see that here we have a node set, which is exactly our lower boundary. Then I'm also going to create some blocks. These are used to define the domains where you want to solve your PDE. So I want to have 2 domains, one for the smaller semicircle and one for the bigger semicircle. Again, you need a name. And this time it's a surface. And I'm going to choose the bigger one and hit apply. And I'm also going to create a smaller domain. So I'm going to delete the ID and choose a new one and click apply. Again, on the left side, we now have 2 blocks, one for the bigger one for the smaller domain. And the last thing I want to do is assign an element type. So I want to assign element type to both blocks. So I click on both of them while keeping Control pressed. Those are surfaces, and I want to use second order elements, so I choose quad 9. And again, I hit apply. Also in this case, again, it looks like nothing happened, but if we look at, for example, our lower boundary, we can now see that we have points in the middle of each side of the element. So at last, I want to save my model. So I click on save, or better save as. And here I can save it as a Cubit file, which is very handy if I want to change my model later. So I do that. However, this is of no use if we want to use the model in openCFS. If you want to use the model in openCFS, you actually have to export the model, and you have to export it as ANSYS CDB. So I'm going to do that. And click on finish. So this is all I have for you today. Thank you very much.